So we have done all the basic problem. We'll do some more problem on the angle of repose. So angle of repose says that if the angle of inclination of a plane is more than tan inverse mu s, it will slip, right? If the theta of plane is greater than tan inverse mu s, what will happen? Object will slip. And if the plane angle is less than tan inverse mu, then it will remain at rest. Correct. So this is what we studied. I hope you all remember this.
Yes, sir.
Now, plane doesn't mean only plane. It could be anything. So let's say there is a hemispherical ball. So it's a ball of this shape. Imagine. Which is fixed. And the inner surface having the coefficient friction between the insect. So there is an insect. And there is a coefficient friction US. And the radius of this ball is capital R. So how high the insect can climb? How high from base insect can climb without slipping. So what do you think? So here it's a hemispherical shape, is a shape in which the inclination will grow as you go up, isn't it?
Yes,
So when the insect is at a location somewhere here, it is a part of a plane of certain inclination. So if you draw a tangent, then you can see that this is the inclination. So as long as this theta is less than tan inverse mu s, it will remain at rest. It will not slip. It will climb easily. So the maximum height depends on the maximum angle, right? Because as height will grow, theta will increase, right? So what is the meaning of maximum height? Which means it is the maximum angle for which the slope is equal to tan inverse mu, right? So basically, the moment tan of theta becomes mu s, it can climb. Beyond this, what will happen? The slope will be more than mu s, and therefore the insect will start falling back. So now it's a geometry problem, and if you assume this angle as theta, then this angle will be how much? Can you guess? This is 90, this is 90 because these are tangents. So this angle is going to be theta only. And therefore, the height the insect can climb can be expressed in terms of theta. So h is how much? It is r minus r cos theta. And because tan theta is mu s, so cos theta will be, and therefore the answer is, is this clear?
Yes, sir.
Okay. So imagine you have a parabolic path and every curve will have a variable slope. Only straight lines are having fixed slope. But whenever there is a curve, there is a variable slope. If I say the equation of this curve, we write as y equals to ax square. And on this curve, again an insect starts climbing. So the question is again how high it can climb. What is y max? Find, and the coefficient of friction is given as mu s between the insect and the curve. So find maximum height attained by the insect without these all are JEE kind of questions you will come across in the mains or advanced. So angle of repose is the one of the most authentic, you can say, I mean, kind of question you will face in examination. And one should be very good with the idea of angle of repose. So as you climb the slope or this curve, the slope will increase or decrease.
Increase.
And because the slope will grow with height, it means at some point it will be enough. I mean, it will exceed the angle of repose, and beyond that, if you try to walk, you will start slipping back. So solve it. Tell me the answer. Then
No, sir, still doing.
how to find the slope of a curve? Then so slope means what? Dy by dx is called slope, right?
Yes, sir.
I can solve. Very nice. So now dy dx is 2x. This is called slope, right? And the slope should be how much? If you're drawing a tangent here, the slope represents this angle, right? Tan theta. And you can climb only up to the how much? Up to mu s. So x is how much? So this is the maximum horizontal distance you can go. So what is the maximum height you can go? You can see the answer is mu square by 4a. So the maximum height that the insect can climb is mu square upon 4a. Instead of insect, they may use a bead that at what angle the bead will be at rest. The method remains same. So it doesn't matter whether it's a bead or it's an insect. So if you have understood the concept, you can apply anywhere. So there is one more question. Now this is the most important 2-block problem on the inclined plane. So we have an inclined plane. You can do the way you want. So now you can see there are 2 blocks kept side by side. And the coefficient of friction will keep it same for kinetic and static both. So the coefficient of friction between the block and the surface of the plane is mu1 and mu2 respectively. So because we have 2 separate pair of surfaces, so it will have 2 different coefficient of friction. And we have to take multiple cases. Okay. So we have to find the acceleration. Now we can't solve just like this. So there is a rule. Okay, we have to in the examination they will give you condition, but here because nothing is said about mu1, mu2. We do not have the mathematical values. We don't have the theta value. We cannot compare anything, and therefore we'll take all the possible cases that you will come across probably in order to solve question. So case one is, what if mu1 and mu2 both are exceeding tan theta, which means the friction is sufficient to hold both the block at rest individually. Okay. So what will happen? Tell me. If mu1, mu2 both are more than tan theta, it means the surface of the plane will keep both the block at rest respectively. So will they press each other? Yes or no?
No, sir.
So both of I mean, both the blocks will not press each other. They will remain at their respective place without pushing each other because the friction is sufficient to hold them at their respective places. And therefore, I mean, no need to solve anything. The both acceleration will be how much? 0. And they will ask you what is the reaction force between them. So reaction force between blocks will be equal to how much?
0.
0. So we can call name as R12, just to remember that 1 and 2. So the first case was very easy. We have done with the first case. We'll go to the next case. So imagine mu1 is more than tan theta, but mu2 is less than tan theta. So the second block cannot stop it. I mean, the second block is cannot be stopped by the plane, but the first block will try to stop it. So now there is a problem. The one is not trying to move, but two is trying to move. So will they press each other?
Yes, sir.
Now the question is, it is possible that because of the pressing force, it also starts moving, isn't it? So now the question is, what will determine that whether both will move as a whole or not? Because see, the car in front of you, let's say the M1 is something which is trying to be at rest, but M2 is trying to move, so it is going to press, and that force is too much to move both of them. And of course, they will move together only. So the question is how we can determine whether the system will move or not. Tell me. So M1, M2 as a system will move or not depends on what? Can you guess?
Sir, mu1.
What we have to do to come to conclusion? So whether the system will move or not, who will decide?
So if the force exerted by M2 on M1 is more than the force exerted by M1 on M2.
How it is possible? Newton's third law says that force will be equal in opposite. So how it will be more or less? The reaction force cannot be different, no?
So it depends on the frictional force exerted on the system of M1.
Yeah. So who will pull the system down? Which force? So you should take both M1 and M2 as system. Now tell me, on system, which force will take you down or bring you down?
Sir, M1 plus M2 G sin theta.
Very good. So the net gravitational pull, if this will exceed the net limiting friction, the total friction force that together they can develop. So how much friction force they can develop? mu1 m1 g cos theta plus mu2 m2 g cos theta, right? Isn't it?
Yes,
Hello,
sir.
hello, hello.
Yes, sir.
If the net gravitational pull exceed, then I mean this we can rewrite in a very nice way, because G gets cancelled, and there is something really interesting here, which you should learn. mu1 m1 plus mu2 m2. into cos theta, which will imply tan theta exceeding the weighted average of the frictional coefficient. This is the weighted average, right? And we call this as mu effective, which is very nice way of writing. Which means if tan of angle of plane exceed the effective value of mu, then it will again slip down. Then system will slide down the plane together. Then system will slide down the plane together. Okay. Is this clear?
Yes, sir.
And if it will move down the, I mean, if the system will move down the plane together, then the acceleration will be how much? So we can treat the entire system as only one block. And if you remember the formula, it was G sine theta minus mu effective cos theta. No need to mug up. You can write the Newton's laws of motion, net force equals to mass into acceleration for the system, because they are moving together. So we will subtract the two, and you will write m1 plus m2 into a. If you substitute back, you will have the similar answer like this. So this entire term is a very effective way of reducing. So you can always remember this answer itself, and you can substitute in the formula to get the answer. Okay. And once you get the answer, which is G sine theta minus mu effective cos theta, you can also find the reaction force between them. So what will be the reaction force between them? So to find the reaction force between them, to find the reaction force between them, draw a BD of any one block. Why? Because it is internal force, so we have to draw a BD of only one block. So we can draw here as M1G center. We know this answer is mu1 M1G cos theta. Why we are writing like this? Because of the obvious reason. Because it is going down, so it will experience the maximum friction force. And we also know the acceleration, and we know the reaction force. So if you write the Newton's laws of motion, you can say M1G sine theta plus R12 minus mu1 M1G cos theta is M1 into A. So R12 turns out to be mu1 M1 cos theta. I will take M1G common. So it will become mu1 cos theta minus sine theta plus M1 into A. You can take M1 G rather from QQ common. So that A equals to G into sine theta minus mu effective cos theta. And you can take M1G common. Yeah. Yes. I think this is correct. Yes, that's the answer. So there's something interesting answer. So R12 turns out to be M1G cos theta, and the bigger value minus the effective value is going to be less than bigger value, because that's like an average. So you can put M1, M1 plus mu2, M2. And it will turn out to be a very nice answer, which will be appreciate. So mu1, M1, mu2, M2, mu1, M1, mu1, mu1, M2 minus. So this gets cancelled. So what you are left with is M1, M2, G cos theta upon M1 plus M2 into mu1 minus mu2. And the answer we can further write as R12 equals to, this is a reduced mass, right? So how to write it? This says reduced mass, but difficult to remember. But it is like product of mass upon summation of mass into G cos theta into difference of coefficient friction. I could have written like as mu G cos theta into Km minus K2, because reduced mass we write by mu symbol, and I can replace Km and K2 for the mu and mu2 respectively. That's why it will not get you confuse you. But anyway, you can design your way of writing. Or I can add this way. Mu, which is like a reduced mass, G cos theta into difference of coefficient of friction. And you can clearly see that if mu and mu2 are equal, then definitely it will be 0, because both will accelerate with the same acceleration, so they can't press each other. So this is the entire discussion for the second case, case number 2. The third case and fourth case are easy. So case 3. Case 3 is, what if mu1 is less than tan theta and mu2 is more than tan theta? Does it make any sense? So the lower block will go down, correct? And the upper will be at rest only, isn't it? Hello, hello.
Yes.
If mu1 is less than, so only m1 will move and m2 will remain there only. So m2, m1 will never interact. M2 will be there only, because m1 will move and it will not affect m2 in any way. So in that case, it's only one block problem. It is not a two block problem. So we can say A1 is G and A2 is nothing, 0. Is this clear to you guys? Tell me. And case 4 is interesting. If both are less than tan theta. So now again, what will happen? Both will move, right? Hello, hello. If both is less than tan theta, then what will happen? Can you guess?
Both will slip.
Will they slip together or will they slip separately? What do you think?
So separately.
The answer is we can't say. We need some more information. So imagine the block M2 can move faster than M1. It means the acceleration of M2 is more than the acceleration of M1. What will happen? The M2 will hit back the M1. If let's say Ferrari is pushing the Nano, is it possible for Nano to move separately?
No, sir.
Because Ferrari is always faster than Nano, so it will always go together, isn't it? But if the Ferrari is in the front and Nano in the back, then what will happen? They will move separately. Correct? Assume they are using the maximum power possible to drive their vehicle respectively. So when M1, M2 is given, mu1, mu2 is given, we need to check the acceleration value. Which acceleration is bigger? So we know that lesser the coefficient, more the acceleration, isn't it? Hello. So we have to take the case, sub case. And the sub case is if mu1 is less than mu2, which means which one will move faster? So if mu1 is less than mu2, then m1 will accelerate faster than m2. And in such case, both will move separately or together. Is this clear?
Yes,
Both
sir.
will move
Yes, sir.
separately, and we can say then a1 will be equal to g sin theta minus mu1 cos theta, and a2 will be g sin theta minus mu2 cos theta. Is this clear?
Yes.
No. So this is the subcase 1, and then we have the subcase. What if mu1 is more than mu2? Because the block below is trying to move slow, but the block behind is trying to move faster, so the block behind will press each other, isn't it?
Yes, sir.
Yes, sir.
And this and mu1, mu2 both are less than 10 theta, so it means if they will come together downward, right? So both will move together downward. Understood? So since m1 will m2 will try to accelerate faster than m1, therefore both will move together. Is this clear? And once they move together, we know the answer. What is the answer? A1 equals to A2 equals to A equals to G sin theta minus mu effective cos theta. Is this clear? Hello. 1, 2, 3.
Yes, sir.
So we are done. All the cases are done. So this is how you have to solve it. You cannot jump to the question blindly and start attempting. You have to first think about the situation, analyze the situation. You have to write a lot of things, and then you can solve. So this was one of the finest question from the angle of repose, and JEE Advanced has asked such questions. So
So can you show the fourth slide?
yeah. And in the R12, even in this case will be same as this answer. That's very interesting. So whatever be the reason, if they move together, this is going to be the reaction force between them. And these derivations are very crucial. You have to first, do it on your own and keep on doing till you realize it, till kind of develop your own thinking. And if you have not developed, then very difficult. So one should develop the thinking in this way. It takes some time. It's not very easy. I'm not saying it's easy. You may spend one entire day to realize this entire thing. And then you will be really good with the friction chapter. So laws of motion is where you study the basic stuff. Friction is chapter where you start applying. And with the very good idea of friction, you can actually solve the tough question of rotational dynamics. So there you have to think a lot. And only if your friction concept is clear, you can think and you can solve. Otherwise, rotational dynamics is a really nightmare for majority of students across the world. So how many hours are you putting for solving problem, not for studying? I mean, I don't care if you're, sitting at one go for 10 hours or 20 hours. How many hours of problem practice you do in general on a daily basis?
So for physics only,
Yeah, only for physics
so 3 to 4 hours.
per day.
Yes, sir.
Very good. Persons, how many hours you do per day?
So I do it alternate days, 1.5 hour to 2 hours.
That is not at all sufficient. Again, you're doing the same mistake. See, I don't know why you guys are not understanding what I'm saying again and again. I have given you all the idea that you have to follow if you want to crack the competition. What is stopping you to follow? I don't know. 1.5 hours is nothing. In that 1.5 hours, nothing will happen. You will hardly qualify the boards and somehow the CET exams, and that's it. Let me make it very clear. Forget about the JEE-Mains. In JEE-Mains, will get like 70-80%. That's it. Let me give you the realistic picture. That much effort is not going to help any one of you. The competition is like you have to work like a donkey, day in, day out. And that means you have to really understand the subject. Because once you understand the physics, the mechanics part, there's no need to revise mechanics. Mechanics is common. I mean, just ideas, concepts only. So anyone who understands once, it is sufficient. You need not to rework. And if you're not putting that effort, it's like you're putting yourself at the same status quo where you were. So how many hours you study at the weekend? On a weekend, how many hours you study? And what do you think? Weekend is for the fun or weekend is to finish the backlog?
So finishing backlog.
So how many hours you study on weekend?
So 8 to 9 hours when there is a holiday. But I mostly have like pace on Saturdays also.
So on Sunday, how many hours you study?
for around 6 hours after the class.
On Sunday, 6 hours. You have class on Sunday also?
No, sir.
Then how many hours? Only 6 hours.
No, sir. That's on Saturday after the class. On Sunday, I study more, around 10 to 12 hours.
10 to 12 hours. Good. So on Sunday, you should study for at least 12 hours. On Saturday, make it 10 hours minimum. On the rest of the days, you should study for at least 6 hours. On a very consistent manner without fail every day. And the way of learning is simple. When you start a chapter, you come to the end of the chapter, then leave it. So it's not like you have to study for 1 hour and then leave, go to the other chapter. No, this is not how the physics or chemistry maths is learned. You start a chapter, you finish till you get completely consumed for the day. And finish the chapter, because see, every day you're not going to solve, if friction is there, homework, it will require only one day to finish the entire sermon. So once you are done with the sermon, you can go on solving other chapters. And whatever you pick, let's say you start solving limits and continuity. You start and finish and then totally, get yourself consumed in the process, finish end to end, realize the process, kind of do the simple analysis of what you should remember, what you can do, what you cannot do. Make a small list of do's, don'ts, your mistakes, your weakness, your strength, discuss with your teacher, and then come strongly with the next topic. Every chapter to start and then come to its conclusion, then switch to the other topic. It is not like that you will study 2 questions of each chapter daily. That's not how the JEE is prepared. JEE means you have to start and completely, demolish the chapter. That should be the way of learning. And if you're not doing this, you know the consequence. Anyway. I know you all will learn after the failure, but not now, because your brain is not tuned to learn something this way. Once you will fail, once you realize, then only with a setback you will learn. Yeah, there are many people who learn after the setback. They never listen. I mean, it's like a very powerful resistance to what is being said. So let's go to the next kind of question that is again very common and very interesting. So we'll move towards the next or the 2-block problem. So we call 2-block, but it could be 3 also, 4 also. So we have 2 blocks and the coefficient friction between them is less than mu. And I'm taking the bottom as frictionless. So bottom is frictionless and we have 2 blocks M1 and M2. Between the block coefficient of friction is mu, which will represent for mu k also and mu s also. Okay. Now, what we do is we apply a time varying force, a force which can grow with time slowly. So a time varying force, which is proportional to time, is applied, and we can attach some constant into t. T is the time. So definitely when T is 0, the force is 0, it means you are applying nothing. But as you keep on, as the time will grow, the force will grow in value. And M1 will experience greater and greater force. Okay. Okay. So F equals to KT by T, then what will happen? As the time will grow, the force will try to move the block M1. The driving force is acting on the upper block. And so the upper block will try to move towards the right. So it will experience the friction on the left. And that friction will have the reaction on the M2 towards the right. So M2 will also try to move towards the right. So we have no idea whether they will move together or whether they will move separately. Do we know as of now? Do we know whether they will move together or separately?
No, sir.
We have no idea actually. We are totally clueless. What will happen? We have no idea. So when you are solving a 2-block or 3-block or 4-block problem, always remember that to move separately, you have to overcome the limiting friction. But to move together, the friction is always less than limiting. So the event which is demanding less will occur first. That's very interesting. So in a 2-block problem, the first thing we do is we always look for the condition when they will be moving together. Or in a way, you can say we will first consider the case that let's say they are moving together. And if the assumption that they will move together is giving you the friction force, which is exceeding the maximum friction available, it means this condition cannot be met. So imagine to move together, you need a 10 Newton frictional force between the blocks. But because of the values given, the maximum limiting friction I can develop is only 8 Newton. So no matter what I will do, they will move separately. But imagine if the friction force required for them to move together is 10 Newton, but the maximum friction available is 12 Newton. Then the deal will be done and they will move together only with the how much force? How much friction force between them? 10 Newton, because 10 is sufficient to move, right? And you can generate up to 12 Newton. So if 10 is sufficient to move together, it will move together with that force. So the rule of solving 2-block problem is very simple. First of all, you have to do some checkpoint. So I think this is okay. So first of all, let's write the checkpoint. So always do some checkpoint. I mean, don't solve first. You check something, what you have, what you can do. Find limiting friction between pair of surfaces. So luckily here we have only two pair of surface, out of which only one is rough, other is smooth, and therefore you have only one checkpoint. So what is the limiting friction that we can generate there? Can you tell me the answer? How much friction force you can generate there maximum? Hello, tell me. Am I audible, guys? Am I audible?
Yes.
Yes, so
Yeah, so tell me, no? How much friction force we can generate or develop between the blocks? Come on. How to find the limiting friction between the surface? Draw the ABD for every block first. We have done this ABD practice in the very first lecture. Tell me the ABD first. So it is experiencing force KT, and because the tendency is to go right, it will experience friction left, and the M2 will experience the friction right, and it will experience the normal here and the normal here, and it will experience the gravity. So what is the limiting friction value between the blocks?
So there has to be a friction force with the ground also.
No,
Oh, mu zero.
mu 0, right?
Yes.
See, limiting friction, when I ask limiting friction, it means what is the maximum value we can generate? It is like the money in your pocket before you go to some market or some shopping mall and you buy stuff. So how much money you carry in your pocket is like asking what is the limiting friction. So mu s is how much? Mu s is here given as mu. And what is the normal force between the block?
M1G.
So this is the limiting friction you can develop. It is like the money in your pocket. If required, you can go up to this value. Is this clear?
Yes.
So now this is the checkpoint. You have done the checkpoint. We don't have any other checkpoint. We are done. Okay. What is the case 2? you can find the acceleration of each block separately. What is the acceleration of A1? If you write the laws of motion, what will be A1?
So
Come on,
KT
guys.
minus mu M1G by M1.
No. You will only write FC right now. You do not know whether they are slipping or moving together. So to write the value, I'll tell you how to write. There, first of all, you have to understand, okay, assume if they are moving separately. I mean, if they have the different acceleration, we are just denoting by unit. I'm not saying they are going to be different. I'm denoting. So let A1 equals to the acceleration of the first block, which will be KT minus F upon M1. That's it. Net force upon mass. And A2 equals to how much? Tell me. A2 equals to?
So why is it KT minus F?
Because this will go towards right. So what is the net force? I mean, what is Newton's law? Net force equals to mass into acceleration. Is it difficult to understand the Newton's second law? Like how you write the Newton's law of motion on for every block, anything. What do you write? Net force equals to mass into acceleration, no? Or you write something
Yes.
else.
No, sir. That only.
So acceleration is how much? Net force upon mass.
Yes, sir.
So what you will write for the acceleration of M1? Tell me.
KT minus F is equal to M1A. A1.
M1, right? Very good. So what is A1 coming? KT minus F by M1, right?
Yeah.
Similarly, what is A2? Tell me.
Mu M1G by M2.
Come on, guys. What I said, you have no idea about F. You can't take F as some value. F is only F because you have no idea whether it is slipping or not. You have no idea whether the friction has reached the limiting value or not. Do you know anything?
No, sir.
So when you do not know anything, then you use a symbol F and you will write the
F by
answer.
M2.
F by M2.
That's it. So the first step is keep a variable F and solve in terms of F and just write the answer. This is not the answer. This is the way of writing the acceleration. I'm not saying this is answer of this question. No. We haven't reached the answer. Then we'll take the case one. So the next part is called assumption. So what is assumption? Let M1 and M2 are moving. See, the friction between the block will act as a glue. And if the glue is sufficient, they will move together. They will move together, right? So because the friction between the block may act as a glue, they may move together. You have no idea. So the two block problem is difficult because you have to go through a lot of assumption, and this will take some time for your subconscious mind to absorb it. So it is not going to happen in one day. Only if you spend time to realize this, maybe in 1 week or 1 day or one fine day, you will realize this process. So this is going to be a long-term process. I mean, first you will study, you will realize, and your subconscious brain will keep on trying to absorb this entire thing. And when you will revise this topic again, maybe after 1 week or 2 weeks, then only you will actually understand. So you have to revise this topic at least twice. Revise at least twice. This is the basic stuff. Okay. So if you assume that they are moving together, which means A1 equals to A2, and then this implies KT minus F by M1 is F by M2, and you can write as KT by M1 and F1 by M1, 1 by F2, and therefore this will give you F value. What is F coming? M2 KT upon so now this is the answer, which is not the answer again. This is the value which we are getting. And what you can realize, I know it's difficult. So the friction is coming as a function of time t. So as time will grow, friction will also grow in value, right? And it will grow linearly with a slope of how much? So what is the slope of this graph? Any guess? So tan theta is how much? Nothing will answer. Right? Y equals to mx. This is the form of y equals to mx. What is m here? No idea.
Sir, M2K plus M1 plus M2.
Okay, you guys don't understand maths and physics together, right? You either understand math, you either understand physics. But if there is a relation, you don't understand, right? No problem. So the slope of this graph is m2k by am1 plus m2, because see, the t is like x and the f is like y. So whatever is the coefficient of x is the slope, isn't it? Hello.
Yes, sir.
In it. Now the friction force is growing with time. So what is the condition to move together? Condition to move together? Any guess? The friction develop. This is the friction which we need to move together. And what is the friction which we have available here? So this is a need. We need this much friction for them to move together. And what is the available value? So condition will be what? The friction you need for them to move together should be less than equals to what is available. So if you want to buy something, then the money in your pocket should be either equal to or less than, the price of the object should be equals to the money in your pocket or less than money in your pocket. Then only you can buy. So for the block to move together, the friction that is developed should be either less than or equals to mu m1g, which is the net available. Do you realize this?
Yes.
And this gives you the condition that T is less than mu. Let this term as T naught. Let's call this as T naught. So when T is less than T naught, they will move together. And if they will move together, which I have ascertained, no, we have come, kind of arrived at the condition that, okay, if they are moving together, then what will be the acceleration? Then what is A1? A1 will be same as A2. So for T less than T naught, A1, A2 will be equals to A. And because they are moving together, you can treat as a system. So no need to solve like this. You can just solve this way. On this system, what is the net force acting on the system? Any guess? What is the net force acting on the system? Tell me, guys. The net force acting on the system
KT.
is only KT. And what is the net mass of system? So no need to solve the way we did. Just this is answer. Okay. So the question is, if, or you can say for T exceeding T naught, what will happen? If T exceed this T naught, what will happen? Will they move together? The answer is no. Because if T is more than T naught, it means it will not fulfill the condition of moving together, which means the friction force cannot attain the value which is required for them to move together. And when this will happen, then they will definitely move separately. But the good thing is, once the block will start moving separately, the friction will be kinetic friction, whose formula is always known, mu into n. The friction force will change its nature from static to kinetic. Therefore, the F will become mu n, and therefore you can just substitute the value of n, which you have known. And once you know the friction value, then you can solve the question. A1 was how much? AT minus F, but F is now Fk. This is the answer, and A2 will be F by M2. Is this clear? Hello, hello, hello.
Yes.
And what you can realize that A1 will have time dependent relation, but A2 will be constant, isn't it? Do you realize this? Because M2
Yes.
will only receive the Fk value of force when it is slipping. But A1 will keep on accelerating faster and faster because the KT will keep on growing. but the friction force is constant. So there is a constant force acting. So they will ask you, can you plot the graph of acceleration versus time for both the object blocks? So if you plot a graph between acceleration and the time, for a quite a lot time, they will move together. So they will have same acceleration, kt upon m1 plus m2. And this will be when they are moving together. And we know the answer, it's kt upon. But this is up to t naught. Beyond t naught, the A2 will move constant to acceleration. And A1 will move with time dependent acceleration. And you can see I have increased the slope. So if this is alpha, this is beta. And you can clearly see why it is alpha and beta. So here the slope is, so tan alpha you can clearly see is k upon m1 plus m2. But you can see here tan beta is how much? K by m1, right? If you know mathematics, y equals to mx plus c. And therefore, which one is bigger? K by m1 or k by m1 plus m2? Which one is bigger?
K by M1.
Which means when they move separately, or you can say relatively, then it will move with greater acceleration than before. Not only value, with you can say slope also. So that's why the graph makes sense. And definitely this is not so easy. Okay. So take your time to realize, absorb, and create some process in your brain. Then I'll give you some other way of thinking. There are many ways of thinking. This is a way in which, if you proceed, you will get the right answer always. But we have some other way of thinking also, in which what you're supposed to do is, you believe that they will move together. So method 2 is start with the assumption. Start with assumption that they are moving together and find its acceleration. So this is easy, right? If I do this, so I'll get A question. And remember, this is a checkpoint. So A equals to how much? I mean, I'm not solving. This is all assumption only. Step 2. Draw FBD of either block. Don't draw for all block, but choose the block which is easy. So I will draw for the M2 block. You know why? You know why? Because for M2, the only driving force is friction. And then I can write F equals to M2 into A, and I got the A actually. It is clear? Step 3. Compare F with Fs max. So we know F is if F is less than Fs max, they will move together. So the A assumed will be the answer. So whatever you started with the assumption, that is your answer. No need to change. If F is more than Fs max, assumption fails. Friction changes nature. So F will change to Fk, and we know the formula. So redraw ABD with kinetic friction and simply solve for acceleration. So again, take your time, read this process, and we'll proceed. Once you understand this process, just let me know. I will go to the problem. Is the process clear to all of you?
Yes, sir.
Okay. So I have shared the resonance sheet for the reflection. Yes or no?
Yes, sir.
Open it. And we'll go to the page number 5. As you can see. It's called miscellaneous questions, section C. So you can see there are 4 questions actually, and you're supposed to find the acceleration and the friction forces between them or involved. So I'll solve one of them, and then you will try to apply the rest. Uh, I'll take the second option because that's interesting. First is very easy, so I'm not taking it. So both values are 0.5. This is 5 kg, this is 10 kg. And we have a surface. And a 30 Newton force is applied. Okay. If you take both as a system, what will be the net external force acting on the system? Any guess?
30 Newton.
Oh, but here both surfaces are rough. So ground will also exert some friction, isn't it? Remember, system is only block, not the earth surface. Is earth our system? No. So can you, or will you change your answer now? How much ground will apply force? If it will, if it will move together, the ground is going to rub, right? So which friction will act? Static or kinetic? Between 10 kg block and the ground, which friction will act? Static or kinetic? Tell me,
Kinetic.
guys. And do you know the formula for kinetic? Yes or no? Do you know formula for static? Sorry, kinetic.
Yes, sir.
What is the formula?
Mu K into N.
Okay, so what is mu here given?
0.5.
What is n there?
100 Newton.
N is 100. Are you sure?
So 150.
Yeah, it's 150. The normal at the bottom is balancing the entire weight, right?
Yes, sir. 150.
So 150 into 0.5 is how much? 75 Newton.
Yes, sir.
So applied force is 30 and ground can apply 75, which means will it ever move? Will it ever move together?
No, sir.
Which means the assumption that it will move together is null and void as of now itself. So we don't need to proceed further. So one thing is clear that they will never move together. Now try to find the what is the maximum friction between the block. What is the friction we can develop between the block? 0.5 into hello. Okay, you don't know how to find the normal, right?
0.5 into 5 into
5.
10. 0.5 into 50.
It is how much?
25.
So 25 Newton is the force which can be developed between the block. And the same 25 will act on the 10 kg also in worst case scenario. But how much ground can develop? It is 75. So no matter what, 10 kg will never move. Yes or no? If you draw the ABD, it was the friction which could have moved the 10 kg, isn't it? But is that sufficient force?
No, sir.
See, one thing is clear that 5 kg will move separately. So 5 kg will experience 30 Newton this way and 25 Newton this way. So what will be the acceleration of the 5 kg? 1 meter per second square, right? And if you draw the 10 kg ABD, it will only experience 25 Newton. But the bottom can develop up to 75 Newton. So how much friction it will act this way? What is the friction force acting here? Tell me. How much friction will act here? Tell me. Tell me if you're not getting anything. Tell me. So I'm not getting anything. Totally clueless. I don't know what is physics, how to do ABD. I have no idea. You can tell. At least it will be on record. I have discussed the driving force, how it starts. So the 30 is the driving force, right? So from there, we have to proceed to the other ABD, right?
Yes, sir. It's 50 Newton.
So how much is this friction force here?
50.
Huh?
So 75.
All are the mistake. If I am pulling you with 25 Newton, why you will apply 75?
That's fine. Okay,
75
got
is
it.
what you can develop. But I am only pulling by 25, so ground will develop how much?
So 25. Got it.
To keep it at rest, that's it. So that's why the accession of A2 is 0. 10 kg will only move when you exceed 75 Newton force. So to solve question, you have to think organically. You have to think a lot actually. Can you solve the 1, 3, and 4? Think logically, then I'll solve. Solve 1, 3, and 4. Got the answer?
Sir, on the fourth.
So in the case one, because there is no friction between the blocks, so motion of the 5 kg will never affect 10 kgs. It will remain at rest. So you can see the answer. The 10 kg will be 0 and 5 kg will be 3 meter per second, right? In the question number 3, because the force is on the 10 kg block and the maximum friction that the bottom can create is 75. So we may assume that they may move together. And the net force will be 200 minus 75, which is 125 upon 15 is how much? So 125 by 15.
So can you please solve the third one?
You can do every question you can do mentally. First of all, how much maximum friction bottom can generate? 75, right?
Yes, sir.
How much force you are applying on the 10 kg
200.
block? 200. So is it possible for the 200 the 10 kg block to move? The answer is yes, it is possible. So net force on the system is how much? You will assume that system is, let's say, moving together. So what is the net force on system? 200 minus 75, which is 125 upon 15. So if you assume they are moving together, the A will be correct. Sorry. A will be how much? We have done this right. Now what we'll do is we'll draw the ABD of the top block because that's easy. Because the 5 kg block will move because of friction force itself. And we'll assume the acceleration which we have got. So F equals to MA, which is. But how much friction we can develop? Fs max we can develop between the block is how much? Only 25 Newton. So which one is bigger? Fs max or 125 by 3?
So can you explain how you got FS max?
But the formula mu into n, come on. Every time you're asking the same question. Fs max having fixed formula, no, mu into n. What is n there? 50. You guys are not getting the friction formula itself. What I can do? You need to know the ABD. If you don't know ABD, then what I can, how can I can help? Shall I keep on teaching the ABD of the log motion chapter? So what you study there then? So F is 5 into A. Fs max is mu into n. What is mu given for the block between the blocks? Tell me.
0.5.
And what is n there? What is the normal reaction? What is normal reaction?
So 150.
150. Are normal reaction between the block, beta. Between the block we are solving.
So then 50.
So Fs max will be how much?
50 into 0.5.
How much?
25.
So we got 25. So what we are solving, see, we have realized that they are moving together or they can move together. So first we assume, let's say they are moving together and we simply solve. We get some answer. Let's call this as A combined. And what I said, we have to check whether the friction is the friction which we need for them to move together. Can we really develop that? So for that, I draw the ABD of the 5 kg block, and as per the assumption, this is the force required. I need 41.666 Newton of force for the block to move together. But how much force we can develop actually? The force which we can develop between the block is only 25 Newton. So what we need is more than what we have, isn't it? Hello.
Yes, sure.
Which means they will never move together. So if they will not move together, they will move separately. And if they move separately, you have to draw the ABD of each block separately and solve it. Because in that case, the friction is kinetic friction, which we know the formula. So what will be the answer for 5 kg? So 5 kg will experience 25 Newton. So A1 will be 5 meter per second square. And for 10 kg, it is 200. It is 75. It is 25. So 200 minus 100 is 100. By 10 is 10. Do you realize this? The ABD part. You have to do on your own. I mean, see, you have to understand that you have to do on your own, drawing the ABD and getting the answer. The step is simple. You will assume that, let's say they are moving together. Is it possible for them to move together? Yes or no? You decide first. And then solve accordingly. Is this clear?
Yes, sir.
You realize this, how I did. The first assumption is moving together. When something moves together, the friction will be static, which you need to calculate with the assumption itself. And you have to compare against the limiting value, whether the force of friction required for them to move together, is that value more than the limiting or less than limiting? If that is more than limiting, it means the assumption is incorrect. So we'll redraw the diagram, draw the ABD separately and solve it. Then solve the next, the fourth one. Tell me first of all, how you're going to start. What is your thinking process? You explain to me first. Do you have any thinking process in your brain established as of now?
Yes.
Yeah, tell me person, sir. Do you have any process, thinking process?
Yes, sure.
So to explain the process first, what you think and what you do to come to the answer. What happened? Why not just explaining?
So first we assume that the blocks will move together.
So you have to first find out, okay, is the net force acting on the block? The applied force is, first of all, is the applied force more than the frictional force at the bottom?
Yes, sir.
It means they can move together. Now, if they move together, then what will be the acceleration? If they move together, then what will be the acceleration of the system? Tell me.
So net force by total mass.
Net force by total mass. Okay. So what is the answer? What is the net force by total mass? No idea.
So 6 meter per second.
Hmm?
6 meter per second.
Okay, what is the net force?
19 Newton.
90 is net force. Are you sure?
It's the fourth question. No?
Yeah, fourth question. See, external forces are any force which acts beyond the bodies. So ground is which force? Ground will also exert the friction, na? We have discussed this.
So 90 minus the friction applied by the ground.
How much is that force?
15. 15 Newton.
Ground can apply how much friction? What the maximum friction ground can create?
75 Newton.
And how much force you are applying?
90.
It means it can move. The first assumption is correct. It can move.
Yes, sir.
If it can move, then what is the net force?
15 Newton.
So what is the acceleration of
1
system?
meter.
1 meter per second square.
This is with the assumption that it will move together, but we are not sure that this assumption is correct or not. So what we'll do, we'll draw the ABD of other block or any one of the block to get the actual friction between them with this acceleration. Like to have 1 meter per second square, how much acceleration is, how much friction is required. So if you draw the ABD of 5 kg block, the friction will act in which direction?
The right side.
And how much it will be?
0.5 into 50.
Come on, you have no idea what you're doing.
25.
It is 5 Newton only. The ABD says F is the only force acting on the 5 kg, mass is 5 kg, acceleration is 1 meter per second square, which we have got with the assumption. Then friction is how much? Only 5 Newton.
Yes, sir,
We
5
need
Newton.
only 5 Newton to move together. And how much we can develop? 25. So what we can develop and what we need is less. No? So it means it will move together. So answer is correct. So the answer is 1 meter per second square. That's the answer for the question. The checkpoint is to check whether the force required for the system to move together, is that force sufficient or less than what is available between the block. I don't think you have realized the friction. Yeah, it's difficult. I have been teaching this for years, but only fraction, a very small fraction, understand. No one understands. I don't know why. So you understood the process? No.
Yes, sir.
Let me explain the process. You assume first of all, you have to see that whether sometimes it is at the very first we can say that it can't move together. Okay. because the opposing force is more than applied force, so it can't move together. And when they don't move together, you do the individual analysis. That's it. Okay. Come to page number 8, everyone. So on page 8, again, we have the match the column. It's very interesting question, not very easy. It's very difficult for many of you. So there's a lot of thinking actually. I mean, what I will suggest that you revisit these pages, try to first, absorb the process. And, recap the process in your brain. Try to first recall the process. And then solve a question. It will take maybe 1 hour, but that's okay. So solve question number 2. Once you're done with the 2, I'll solve the match the column on page 8. The 2 is easier, so you try the 2 first. 1 I'll take care. Part 3, second. Think about it. Take your time. Okay, so I hope you are done with the questions. Siddhant, you did the question?
Yes, sir. Done.
Okay, very good. Don't worry. See, I know it's difficult. I might be shouting on you, but it will take some time for you to realize. So keep on watching, keep on revising this lecture. You will realize what I'm saying. Okay. Prasansa, you got the answer?
Yes, sir.
Okay. So the first is, okay, I'll just do it manually, mentally. So in the P case, tell me, I think friction is given, no? But ground is frictionless, I think, right?
Yes, sir.
Yes, sir.
Yeah, now it's simple. So now if I assume, okay, they will move together in the first case, P case. So what will be the acceleration? 12/6, which is 2. Correct?
Yes, sir.
Now if 2 is the acceleration, who will move the 2 kg block? Only friction. So friction is the net force acting on the 2 kg block. So F equals to mass into acceleration, which is 2 to the 4. So friction acting is 4 Newton, and it is said that the friction is very high, no matter what. So it will move together only. I hope this is clear.
Yes, sir.
So for P, what is the answer? Friction is? Four Newton. And the acceleration is how much?
2 meters. Yes.
For Q, it is again the A is 2 because it's the same answer. And what about the friction? So it is now the friction is moving the 4 kg block. So 4 into 2, which is 8 Newton. In the R, again A will be something same. But to draw the ABD, okay, you need to understand something here. So here, if you think 2 kg and 4 kg individually, because see, the difficulty is right now you don't know which one will go for, I mean, faster than other. So if you have to assume, let's say there is no friction, and then we can check that 2 kg will try to move faster than 4 kg because of the greater acceleration, and therefore friction on 2 kg will be backward, and 4 kg will be forward. So the way of solving will be 6 minus F equals to 2 into 2. So F turns out to be 2. And the S will be A is going to be same in each case. 12 minus 8 by 6. But now if you look at the ABD is simple because the net acceleration is towards the right. So for 2 kg, the friction force will act forward and 8 is acting backward. And so it is F minus 8 equals to 2 into 2, F is 12. So we have all the friction and acceleration. And you can clearly see the magnitude of frictional force is maximum for the S, right? So A will go with S. And the magnitude of friction is least is R, right? And C is friction force on 2 kg block is towards right. So that's S. And D is towards left. So which case it was left? R. Okay. Done. This is the answer. SR. I think one more. Friction is left on 6 kg or so. So 6 kg R. The left is R also. And U also. So friction force on 2 kg block is left on Q also. And R also. That's it. And friction force on 2 kg block is right will be S. Oh, what I
And
did.
P also.
No, this is a D. So this is C, no? C is only S was there.
P.
And P. Which one P, no?
Yes, sir.
Yes,
P.
so P.
And rest is done. So this is the answer. So similarly, can you think about question number 1? I mean, that's again very interesting. See, when we have two blocks and you are confused with which one will go faster, the rule I have explained in the very first lecture, assume there is no friction. And if you assume there is no friction, then you can check their acceleration. And from there, you can compare which one will move faster. So this is how you have to think about the question 1, so that you will try at home. And you solve the exercise 1 completely from the resonance sheet and solve the SC Verma completely. And once you're done with the 2, you can start solving the exercise 2. Before the next class, you have to finish exercise 1 and SC Verma both. Exercise 2, you can keep on doing as you know the next chapter comes into picture. You can keep on doing because for the next chapter, the question will come after some time. So you can meanwhile finish it. Okay. Say don't take more than 2-3 days to finish any chapter, whether it's physics, chemistry, maths. And devote more time. Don't take it lightly. And now we are going to start the circular motion in the next lecture. Okay. So bye and take care. You have time to practice. I think one more variety I will discuss. Just a moment. No, don't go. One more variety I simply missed it. So this is something very interesting. And these questions are solved only with the common sense. And I got 2-3 varieties. Okay. So 4, 6, 10, 10, 6, 16. So you're supposed to find the tension force in each string and friction force acting on each block. Think for a while, then also. Good answer, Siddhant?
Sir, almost all.
So to solve this question, you have to first find the driving force. So your driving force is how much? It is 50 Newton, right? Because that gravity will pull.
Yes, sir.
Now the idea is we have to check the net friction force, sum of the all friction. Sum of all Fs max, and this will turn out to be how much? Mu mg, so it will become 4 plus 6 plus 6, right? Which is, so which force is bigger? The net friction or the driving force?
So net friction.
Net friction.
Which means it will never move, right?
Yes, sir.
Because the sum of the friction you cannot overcome. So the idea is you will never ever move, which means the acceleration will be 0. So now it's simple. Once we realize this, the tension will be 15 Newton because it's not moving, so net force is 0. So the T is balancing this one. Then this block is pulled by. Now, once you try to pull the 1 kg block, the friction at the bottom will first oppose because the force will transfer from here to here. But the friction can only act how much? It is only 4 Newton, right? Because 15 cannot be balanced by 4, right? So who will balance the rest? It is a tension. So how much tension will be acting there? 11 Newton. The same 11 will reach here. But 2 kg will try to oppose by 6 Newton. But 11 cannot be balanced by 6. So we need to apply some force. How much?
5.
And so the 5 will act here. But here friction can go up to 6 Newton. We need only 5, so it will balance. This is the answer. No need to solve, just we have to write like this. So the friction force. So the rule is you have to think of the you have to think from the driving side what will happen, and then you have to proceed accordingly and keep on attaching the values. These kind of questions sometimes become indeterminate in some scenario, so that depends on the question. If you come across, then definitely you can ask. If the net friction is less than the driving force, it will accelerate, and then you know how to solve. And the last question is the chain problem, which is very, very crucial, important. So, okay. Imagine there's a table. And we have a chain. And it's a rough table. This is the so the total length is L, but out of L length, X is hanging and L minus X is on the table. Okay. So what is the driving force here? So driving force will come from the hanging weight, right? The weight of the hanging part of the chain. Do you realize this? And gravity will
Yes,
try
sir.
to pull that part, but as the chain will try to move right, the friction will try to oppose it. So the question is, what is the maximum X we can hang without slipping? Find X max for equilibrium. So as the driving force will exceed, the friction will have to increase the value, and the maximum friction we can apply is how much? Fs max equals to net driving force, isn't it? So for X max, find X max for equilibrium. So equilibrium is net force is balanced. So driving force acting downward and the friction acting left on the part of the chain on the table, both will balance out each other. And Fs max is how much? Mu into N. N is how much? The weight of the chain on the table, because that will create the normal. And the weight of the chain on the table is how much? So we can assume the lambda is the linear mass density. So lambda L minus X is the mass into G. So you can always use lambda. And driving force is how much? mass into G. Where lambda is, of course, if I hope you know lambda. And once you solve, the lambda and G gets cancelled. And mu s L minus X is X actually. So L by X minus 1 is mu s. So L by X is 1 plus mu s. So X is. So we can't hang more than this value of the chain. Okay. Is it clear?
Yes, sir.
So the friction will try to stop it. Oh, my bad. I made a mistake. So L by X minus 1 is 1 by mu, right? That's why I'm saying something is wrong. So this will be 1 by mu, correct? Okay. Is this clear? Generally, they give the ratio and they will ask you the mu s. So all kind of question will come from here. This is very, very important question. So now there are many other variety of questions which you come across once you reach that level of question. So the more you solve, the more difficulty you will face. So it's up to you that what difficulty you want to achieve. So exercise 1 is the bare minimum that one should be good with for the examination like CET and some easy question of JEE-Mains. For advanced, you have to master the exercise 2. And to get very good rank in IIT, you have to also master the ALP problems. So decide your goal and achieve your target. Make your goal reasonable as per your effort only. Don't make goals which is not matching your effort. If your effort is very small, make the goal also very small as possible. And if you aim high, you start working harder. There is no shortcut actually. I mean, to be very honest, I may convince you that no, this way is okay, you can do something good. These all are like lies. And I don't want to tell lies to you guys. It will be difficult to digest.